Welcome, Hornets, and thank you for joining me today. Today I'm going to be going over working with the washer method utilizing a vertical shift. I have some problems that we're going to be working with that I used today in class, specifically these problems here. So we're going to be taking a look at these. They are currently set up as a disk method, and I will be showing you the graph and graphing them and then doing the disk method with them. And then I'm going to show you how we move and adjust the axis of rotation. If all goes well, this will be a very useful tool for you to work with, and that is my hope. So let's go ahead and begin. We're going to be taking a look at number 3 here. We're going to be drawing y equals x squared plus 2, y equals 2, x equals 2, and the axis of rotation is currently the y equals 2. So we're going to graph this right now. So I'm going to start off by drawing a general axis. Then I'm going to start putting all of my pieces into it. So we're going to start off with the quadratic that opens up. Again, we're just drawing a general sketch. Then we have the horizontal line. This is y equals 2. And let's use a blue. And right here is my x going straight down and straight up. Okay, and that was x equals 2. So we're now going to put in our information. This is my axis of rotation after all, and we're looking for our r of x. This point down here is x comma 2. This point right up here is x comma x squared plus 2. Now keep in mind, we're going to be using the same picture as we rotate our axis and move it around a little bit. Okay? So you'll notice that if I'm looking for my r of x for the disk method, the r of x just comes out as x squared plus 2 minus 2 for x squared. We would then put it into the disk method formula, going from 0 up to 2 for x squared dx. Now, as we do this, keep in mind that this would then give us pi. Integrate, we're looking at 1/4, so we have 1/5, x to the 5th from 0 to 2, and my answer is 32/5 pi. Alrighty. So we're now going to repeat the same process, but we're going to change the axis of rotation. It currently is at x equals 2. We're going to move that axis, and we're going to move it down. So we're going to have a vertical shift of the axis of rotation. We're going to move it down to -3. Shall we? Here we go. Oh, such radicals that we are. Now start by drawing the exact same figure. All right, I'm not going to use the colors again. I'm just going to draw my shape, put it into the axis. I'm now going to put my axis of rotation. Now the new axis of rotation is being shifted down to a -3, way down here. Y equals -3. Now, we have to find the big R and the little r when we're working with the washer method. Notice that when we were working with this first one, there was only one segment to draw from the axis of rotation to the curve. But when I do this problem, notice that starting from my axis of rotation and moving up, there are now two curves to go to. The first is farthest away. Second is a little bit closer. Notice we now have two segments. One is longer than the other. The longer segment is what we call capital R of x. The smaller one is what we call lower r of x. This is x comma negative 3. This point right here is x comma 2. This point right here is the same x comma x squared plus 2. We're still finding our big R of x, and it's the larger segment. It is the upper y minus the lower y. Watch yourself carefully and make sure you use parentheses if it's a binomial. If it's not a binomial, you do not need parentheses, but they are helpful. Notice I use the parenthesis, and I can clearly see the double negative. That means that I end up with x squared plus 5. Finding r of x, upper 2 minus the lower negative 3, and I'm looking at a 5. We're now going to put it into our formula. Pi integration a to b of capital R of x, the quantity squared, minus small r of x, the quantity squared. So if we put this together, we have pi integration. We're still going from 0 to 2. That hasn't changed. But what has is the big R. X squared plus 5, the quantity squared, and the little r, which is now 5 squared dx. This is now what we would work with. And we would end up with an x to the 4th plus 10x squared plus 25 minus 25. And that leaves me with x to the 4th plus 10x squared dx. And this is what we would now integrate. Let's go ahead and now look at taking the same figure, but now we're going to move the axis of rotation up. So let's have our axis of rotation. This time, it's going to end up being, let's call it 9, shall we? Oh, radical that I am. So we're going to draw our figure exactly as we've had it. Notice nothing is changing. There's the x-axis. We are still going from 0 to 2. Let's put in our axis of rotation now. That's going to be way up above, right up here at y equals 9. We're going to locate our r of x, lowercase r of x. Always go from the axis of rotation to each curve. One first, one second. This point right here, we know already is x comma 2. This point, since it's the same graph, is x comma x squared plus 2. What's changing is this point up here, x comma 9. Now we work with the upper minus lower, upper minus lower. Identify the larger segment as the big R of x, the smaller segment as the lowercase r of x. Finding big R of x. 9 minus 2. Well, that's just 7. Big R of x, or little r of x, excuse me. 9 minus the binomial, x squared plus 2, the quantity squared. This is going to give me 9 minus 4 is 5, minus 4x squared minus x to the 4th. Putting it into my formula, pi integration 0 to 2. Notice that hasn't changed. It's the information that we're putting next. 7 squared minus 5 minus 4x squared minus x to the 4th dx. Now let's make a couple of notes and make some observations, because I'd like you to compare these two formulas. Do you see how the axis of rotation is down below? When it's down below, your upper minus lower creates this quadratic as the upper equation. Then we go to the lower, and notice that's going to be a constant, which means that the constant comes after the polynomial, when our axis of rotation is below. That reverses when the axis of rotation is above. Notice that the constant is now on top, and the binomial is down below, or the polynomial in this case. Okay? Now, that's the idea of a horizontal shift. Making sure that you follow along, draw the axis of rotation, and from the axis of rotation, draw a perpendicular segment to each of the curves, going up or going down. As you do that, locate the larger segment as big R of x, smaller segment as smaller R of x, put them into the formula, and then do your process. All righty, let's try another problem. Okay, we're now going to go to number 4, and we're going to use number 4 as our model to do these problems. Notice that it is already set up as a disk method. It is not a washer method as it is now. So we're going to draw it, we're going to see what it looks like, then we're going to move it around, and we're going to see those same relationships that we saw before. Here we go. We have y equals the square root of x, the quantity, plus 2, from y equals 2 to x equals 1, which means that we're looking at an intersection at 0, 2. So we're going to be going from 0 to 1 in our integration. Here we go. Let's draw it. Start off, and I'm going to use the different colors just so I can get an idea of what this looks like. I'm going to use my axis of rotation. That's y equals 2. That's a horizontal segment going across. That's what's going to be changing shortly. We have our curve. Let's go ahead and draw our curve in a nice blue color. And this is a square root. And notice that it only goes for segment 1 in length. There it is. That means that we're stopping right here at x equals 1. Our axis of rotation, and we find r of x. From the axis of rotation, we draw to the curve. The curve is x comma square root of x, the quantity, plus 2. Down here, we have x comma 2. Our r of x is the only segment. When there's one segment, we're working with the disk method. So we have pi, integration from 0 to 1 of our r of x. Let's just find our r of x real quickly. Square root of x plus 2 minus 2 means that I'm looking at the square root of x, the quantity squared, dx. Pi integration from 0 to 1 of x dx, and I get pi 1/2 x squared from 0 to 1, and my answer is pi over 2. Once again, this is the disk method. Let's now take the same graph, but we're now going to find our axis of rotation, and we're going to move it way down lower, so let's go to -1. Same curve. Don't change anything yet. Put it into the axis, into the graph. I'm now going to create my axis of rotation. I'm going to put my axis of rotation at -1. Y equals -1. And notice we're still going from 0 to 1. We're now going to make our segments from the axis of rotation up to the curve farthest. Axis of rotation up to the curve that's closest. This point right here is x comma square root of x plus 2. This was x comma 2, but we're looking at x comma negative 1. R of x, lowercase r of x, find what they are. Upper y, square root of x plus 2, minus the negative 1, root x plus 3, small r of x, upper 2 minus negative 1, and we have a 3. Putting it into the formula, pi integration from 0 to 1, big R minus little r dx. And this is now the formula we're working with. We would FOIL it out, so we can clearly see we're going to have a 9 and a minus 9 canceling, leaving us with x plus, and we have 6 root x. Dx. And this is what we would work with. Let's now set up another problem. This time, I'm going to move the axis to y equals 1. We're going to move it up in between. Y equals 1. Draw your segment and your shape. Put it into the x and y axes. Find your axis of rotation. Y equals 1. Goes right in between. Y equals 1. Big R, little r next. From the axis of rotation up. X comma square root of x plus 2. X comma 2. X comma 1. Big R of x. Little r of x. R of x, big R, is going to be the upper, root x plus 2. But now we have minus 1, and this gives me root x plus 1. Little r of x, upper, 2 minus 1. And I have a 1. Putting it into my formula now, I have pi integration still going from 0 to 1. And I have my big R minus my little r. We would now FOIL it, add like terms. Notice we're going to have something very similar to what we had up above. So we would have pi, we're integrating, there went my lights, x plus 2 root x dx. The last one we're going to do is we're going to do the same figure, but I'm going to go ahead and I'm going to have it above. So we're going to go ahead and move it. Let's go ahead and have it at y equals 4, shall we? Here we go. Same figure, same function, but we're now having an axis of rotation that will be y equals 4. Notice that's going to be above the figure. So we draw the shape. Notice there's my axis, just putting it in, getting it right. There's the shape. Extend it just a little bit more so I can put my axis of rotation in. We were using green for the axis of rotation, so let's use green again. That way we can clearly see it. This is now y equals 4. We go from the axis of rotation to the segment farthest away. An axis of rotation closest. We know that this is going to be x comma 4 up top. We know this one is still x comma root x plus 2. We know this is still x comma 2. We have an r of x. We have a lowercase r of x. We have to find them both. So here we go. R of x equals upper 4 minus the lower. Notice it's the larger segment and it's giving me 2. Lowercase r of x. Upper 4 minus. Now this is a binomial, so I'm going to make sure I put parentheses and distribute. I end up with 2 minus root x. Putting it into my formula. Pi integration, still from 0 to 2, 0 to 1. Didn't I say 0 to 2 last? No, we're good. Okay, 0 to 1. Big R, 2 squared, minus little r, 2 minus root x, the quantity squared, dx. We're then going to FOIL. You'll notice I'm going to have a minus 4 and I'm going to have a positive 4. But I'm also going to end up having a positive 4 root x, then a minus x. 0 to 1, pi dx. And there we go. Notice the difference and how I change them at each step. When it's a disk, the axis of rotation is there's only one segment, it's one segment to the curve. The axis of rotation is part of the figure. Once we move the axis of rotation down, it is no longer part of the figure and it creates two segments. One will be larger than the other. The larger is the big R of x, the smaller is the lower R of x, lowercase. We always do upper minus lower, upper y minus lower y. Then we put it into our formula. We simplify in order to evaluate it. If it's in between, it just means that we don't have a double negative. Here we had a double negative because we had a negative y equals. Y equals a negative number. When it's a positive, it'll still be that minus, but there won't be a double negative. When it's above, now it just flips the orientation. So we have upper minus lower, and we just follow our work. I hope this has helped you to understand what we did today in class so that you can perform the same work that everybody else will on Friday when we do this again. Thank you very much for your patience and your consideration, and thank you for paying attention and watching this with me. Please remember, it is very easy to be mean, Hornets, so I hope that you will work hard and be nice and kind to each other. Alrighty? Thank you very much. Please be safe, be well, and try not to be mean to each other. Bye-bye now.